AI agents are everywhere. Software, sales, marketing, video editing, trading, banking, support. This is not the future. It is happening now. One support agent handled the workload of 700 people. It cut resolution time from 11 minutes to 2. Software engineers barely write code anymore. More than 95% of new code is already written by AI, and contract review that took lawyers 360,000 hours a year. Agents do it in seconds.
And spending on agents is headed toward $1 trillion by 2030. Every one of those agents stands on the same 5 pillars: the brain, the loop, the tools, the memory, and reliability. By the end, you will know exactly how they work. I'm Jin, that's Rio, and this is AI Agents. Here's the road. 5 pillars. Chapter 1. The brain. The language model doing the reasoning and what limits it. Chapter 2. The loop. How one goal becomes many steps. Reasoning, acting, observing, and planning. Chapter 3. Tools. How the agent touches the world and who actually executes. Chapter 4. Memory. What the agent knows at each step and what survives between sessions. And Chapter 5. Reliability. Self-critique. Error recovery. Guardrails. And how you measure that an agent actually works.
Chapter 1. The brain, also known as the large language model, the LLM. In this chapter, we'll walk through 3 things. 1. The reasoning engine. 2. Reasoning quality. And 3. Shaping the brain.
At the core of every agent sits a large language model, the brain. While the agent works, the model is doing 3 jobs, over and over. It reads the goal, plus everything that has happened so far. It decides what is the single best next action, and it writes every plan, every message, every final answer. Notice what that means. Every decision the agent will ever make comes out of this one component.
So, it's like the engine in a car. You can upgrade the wheels, the seats, the navigation. The engine still decides how fast you go.
Exactly. And that is the first hard rule of agents. An agent cannot reason better than its model. A weak model with perfect tooling still makes weak decisions. A strong model with modest tooling will surprise you. So when an agent disappoints, check the engine first. Then 3 settings decide how much of that engine you actually get: thinking depth, instructions, and model choice. That's the rest of this chapter. Reasoning quality. Modern models can think before they answer. Chain of thought means the model writes out its intermediate reasoning steps instead of jumping to a conclusion. Extended thinking gives it a real budget for that. Explore the problem. Compare options. Catch its own mistake early. For agents, this matters double. A bad decision doesn't just hurt one answer. It sends the entire run down the wrong path. Deeper thinking. Better planning.
And that's a knob, right? More thinking costs more time and more money per step.
It's the first of several knobs. Here's the next one. The same model behaves very differently under different instructions. The system prompt defines the agent's role, its constraints, its standards, what it must refuse. Prompt design shapes behavior as much as the weights do. And then there's model choice. You don't need the strongest model for every step. A common production pattern. A strong model does the planning and the hard reasoning. A cheaper, faster model executes the routine steps. Cost, latency, quality. You tune that trade-off per step, not per agent.
So the brain is really three decisions: which model, what instructions, and which steps deserve the expensive one.
Chapter 2. The Loop, also known as the agentic loop. In this chapter, we'll walk through three things. 1. The cycle itself. 2. React, live. And 3. Planning. An agent turns one goal into many steps by running a cycle. Perceive. The model reads the current state, the goal, and everything that has happened so far. Reason. It decides the single next action. Act. That action gets executed, and something real happens. Observe. The result comes back into the state. Then the cycle repeats, each iteration knowing more than the last, until the model reads the state and decides the goal is met. That cycle is called the agentic loop. Every agent on the market runs one.
So an agent is not one giant clever answer. It's many small decisions, each one informed by the previous result.
The standard way to structure that cycle has a name: react, reasoning, and acting. The model writes a thought, takes one action, reads the observation, then thinks again. Let's watch it live. This is Otto, our debugging agent. Rio, give it a task.
Otto, checkout on the demo shop is slow. Find the cause and fix it.
Thought 1. Could be the database. Could be the API. Logs first. Action. Read logs. Observation. One query takes 8 seconds. Thought 2. Find that query in the code. Action. Search code. Observation. The cart lookup has no index. Thought 3. Add the index and prove it. Action. Edit file. Then run tests. Observation. Green. Final thought. Goal met. And it reports the fix.
And the whole chain of decisions is right there to read. Thought, action, observation, repeated until done. Nobody scripted a single step of that.
One question remains for the loop. Who decides the order of steps? 3 levels of planning. Implicit. No written plan. Each iteration just picks the best next move. Fine for short tasks. Plan, then execute. The agent first writes the full step list, then works through it. Much better for long tasks and plan revision. The agent updates the plan as results come in. A failed step doesn't end the run. It redraws the route from where it stands.
Like a navigation system. New traffic, new route, same destination. Chapter 3, Tools and Actions, also known as function calling. In this chapter, we'll walk through three things. 1. Tool calling. 2. Tool design. And 3. The harness.
A model alone only produces text. Tools are how an agent affects the world. A tool is a real function. Read a file, query a database, send a request. The model receives the tool list, names, descriptions, and schemas. When it needs one, it writes a structured call. Tool name, arguments. And here is the fact people miss. The model never executes anything. The harness, the program around the model, runs the call and feeds the result back as text. The model asks, the harness does.
So every action an agent takes is a request. Something else always holds the actual keys.
And because the model chooses tools by reading their descriptions, tool design is interface design. 3 rules from production teams: clear names, search code beats helper 2, tight schemas, few parameters, explicit types, no ambiguity, and recoverable error messages. When a call fails, the error text goes straight back into the model's context. File not found, here are the closest matches. That error is a prompt. Write it so the model can correct course on the next step.
So, a good toolset reads like good documentation because the model is its only reader.
Around all of it sits the harness, the runtime. It executes the tool calls. It manages state between iterations. It assembles what the model sees each turn, and it enforces the limits. An iteration cap, a budget, timeouts, permissions. When people say agent, they mean model plus harness. The intelligence is the models. The discipline is the harnesses.
The brain reasons. The harness keeps it honest, which raises the next question. What exactly does the model get to see each turn?
Chapter 4: Memory and Context, also known as the context window. In this chapter, we'll walk through 3 things. 1. Context management. 2. Working memory. And 3. Long-term memory. Everything the model sees in one iteration lives in the context window: the system prompt, the tool list, the goal, and the history so far. 2 hard facts about it: it is measured in tokens, small chunks of text a few characters long, and it is finite. The model rereads all of it, every single turn. So context management is deciding what earns a place in the window right now. It is the scarcest resource in the whole architecture, and it has a subtle failure mode. As the window fills, recall of the middle degrades. The term is context rot.
So, the real question is never how much fits. It's what deserves to be there this turn.
Within a task, the agent has short-term memory, working memory, the conversation itself, plus a scratchpad, where the model writes notes to itself while it works. Findings so far, intermediate results, and the current plan. And when the history grows long, the harness compacts it. Older steps get summarized into a digest, and the originals drop out of the window. The run keeps its knowledge and sheds the bulk.
Like working at a small desk, the page you're writing stays in front of you. Everything else gets filed. Now, the part I hear the most confusion about. When I come back the next day, my assistant still knows my project and my preferences. Is the model learning me?
It isn't. The model's weights froze when training ended. Nothing you type changes them. What you're seeing is long-term memory, and it is engineered. During a run, the agent writes important facts somewhere durable: a memory file, a database, a vector store for search by meaning. Next session, the relevant pieces get retrieved and placed back into the context window. Retrieval, not learning, because when a run ends, the window is wiped completely. Anything that survives survives, because it was deliberately saved.
So, an agent remembers the way a team remembers, not in anyone's head, in the shared documents. Chapter 5. Reliability and Control. This is what separates a demo from a product. In this chapter, we'll walk through 4 things. 1. Reflection. 2. Error recovery. 3. Guardrails. And 4. Evaluation.
First, why this pillar exists. A quick estimate. Suppose every step an agent takes succeeds 90% of the time. The task needs 10 steps. Rio, what are the odds the full run lands?
Intuitively high, 80%.
35.9. To the 10th power. Errors in a chain compound. So reliable agents check their own work. That's reflection. After producing an output, the agent critiques it. Does this actually satisfy the goal? Are there errors? If the critique finds a problem, it retries, with the critique in context. One cheap extra step. Whole classes of sloppy output, gone. Reflection catches bad output, but things also just fail. Tools time out. APIs return errors. Error handling is designed in layers. Retry for transient failures. Most of them resolve on the second attempt. Fallback when a tool keeps failing. Take another path to the same goal and fail gracefully. When the goal truly can't be met, stop cleanly. Report what was done, what wasn't, and why. An agent that says, I could not finish, here is exactly where I stopped, is worth 10 that pretend.
So, the failure story is designed up front, not hoped away.
The guardrails are the boundaries around all of it. Validation. Outputs are checked against rules before they count. Permission gates. Reading is free. Writing, spending, and deleting. Need an explicit grant. Sandboxing. The whole run happens inside an isolated environment, so the worst mistake is contained and human in the loop. Any irreversible action waits for a person. The agent proposes. The gate disposes.
So, you never actually trust the agent? You trust the box you built around it.
The last piece, evaluation. Teams measure agents on task success. Did the ticket get resolved? Did the test pass? Did every claim cite a real source, not on how confident the text sounds? The standard practice. A set of representative tasks run against every change. If a new prompt or a new tool drops the success rate, it doesn't ship. Agents are software. They get regression tests too.
And that's the line between a demo and a product.
It is. And one thing an evaluation will tell you fast. A generic agent doesn't know your systems, your conventions, or your procedures. There's a standard way to teach it those, without retraining anything. That's the next episode.
Let's recap the 5 pillars. The brain. A language model is the reasoning engine, and the agent can never out-reason its model. Thinking depth, the system prompt, and per step model choice decide how close you get. The loop. Perceive, reason, act, observe. Repeat until the goal is met. Thought, action, observation, with a plan that can be revised on the fly. Tools. The model writes structured calls. The harness executes them and holds the keys. And tool design decides whether those calls land. Memory. The context window is the scarcest resource. Working memory gets compacted. Long-term memory is retrieval, not learning, and reliability. Reflect. retry, guard, gate, then measure task success because in a chain, errors compound.
Nothing to add. That's an AI agent.
That's it for today. If you learned something, drop us a like.
And subscribe. There's a lot more where this came from.